Hello and welcome. My name is Mohammed Sharif, and today we're going to discuss an introduction to Cisco ACI. What is Cisco ACI means? ACI means application-centric infrastructure. In order to understand why the reason of calling this solution the Cisco ACI, we need to understand the main objective of the solution itself in order to fully understand what is the name referring to. In the traditional network, we used to subject our application or the business demand based on whatever network protocol we having in the environment. That include the limitation and the capability of the network protocol that's running within the environment itself. So in the traditional network, mainly the router or the switches or the network setup itself is driving or enforcing the behavior of the communication to the application, hence reflecting that to the business requirement and needs. Within Cisco ACI, the entire game got changed. In the Cisco ACI, its main objective is to let the application itself to be the driver on how the network operates, not the other way around. So Cisco ACI introduced a new methodology where the business requirement is the driver in the network itself, hence reflecting that on how we operate our environment and how we do our day-to-day routine. So you can say that the Cisco ACI is changing a lot on how the network operates. We still have the network protocol, we still have the routing and switching. However, the main driver of the IT workflow in general, it will be based on the business requirement rather than how my network setup and what is the capability and the limitation of the network protocols that running in the environment. Now, what is the main benefit of Cisco ACI? Cisco ACI have introduced a lot of features, but one of the major features that separates the Cisco ACI from the traditional network is the automation. Cisco ACI, I believe, have introduced a much more wider space for having the automation in the environment. The automation is widely deployed within Cisco ACI solution, where it can simplify the IT process and workflow and adding agility to the application deployment. And also, moreover, you have also the programmability features within the Cisco ACI. And when we say programmability, we're referring here to the customization, or else you need programmability in your network anyway. You have your routing protocol, unless you need more customization, more fine-tuning in the environment. Cisco ACI have introduced the programmability features in a neat and nice way where you can easily deploy your script in much modern fashion. Now, also one of the cool features the Cisco ACI have introduced is I would say it have hardening and increase the security measures in the environment. It's no longer access list. You have now more restrictive access list, more policy enforcement, and more microsegmentation. Also, the analytical part and the analysis in Cisco ACI reports, it gives you more visibility on how the network behaves. Hence, you can size up and understand the risks that you're going on in the environment. Also, one of the cool features the Cisco ACI introduced workload mobility. Now, when we say workload mobility here, simply we're referring to business continuity demands and disaster recovery sites. Recently, there is an increase on demand on disaster recovery and business continuity. Now, to achieve the disaster recovery and business continuity, and to achieve the seamlessness of shifting the servers from your service or your server from one site into another, you need to increase the network mobility here. Yes, of course, and despite it's achievable on the traditional network, but it requires a lot of complex and designing and a lot of effort to achieve that. In Cisco ACI, it had increased the workload mobility with much more simple action and task. simple action. So I believe one of the cool feature of Cisco ACI is the seamlessness of having multiple DR sites and the manageability to shift one service from one site into another. One of the cool features that Cisco ACI introduced, it's a loop-free environment. You know that the Cisco ACI relies on IB on IB for communication within the solution itself. You no longer need the spanning tree or Ethernet or ARP broadcast to perform the communication or to get to know what is the next hop or whatever. In Cisco ACI, simply the underlay fabric or the component of this Cisco ACI, they speak IB only. No broadcasting, no spanning tree. Hence, you're eliminating the potential of having loop in your environment. Cisco ACI also had introduced more secure solution to the environment. Usually in the traditional network, we used to have what is known as the blacklisting approach, meaning that everything allowed unless you explicitly deny it. Now in Cisco ACI, it's more like a whitelisting approach, meaning everything is blocked unless you whitelisted or allowed. Also, it have changed the model that used in segregation between the network and the VLANs. It no longer use an access list. It's called now contract. It's a new modern fashion of having restrictive policy between network segments with more security capability. Also, Cisco ACI introduced a centralized management feature. And instead of individually logging to each and every device and component to your device, now you have a consolidated unified management server where you can run, where you can operate, manage, monitor, analyze whatever you have in the environment. Now with Cisco ACI, there is a new role for a server. It's called the APEX server. It's simply a Cisco UCS server. And the main functionality and the main purpose of this server, actually, it's not one server. It's a cluster consists of 3 active servers that works at the same time. So the main functionality of those servers is to have a centralized management for the entire network, or I would say fabric. And this is the right word of referring to ACI network. So you no longer need to SSH to each and every device in the environment. Now you have a management server where it consolidates everything together into one unified server. Okay. Now we'll discuss the ACI topology and the hardware. In Cisco ACI, I would say in the traditional network, each network it's having a certain design and certain setup based on the nature of the enterprise that you work that the network working on. For instance, the service provider is having the network design different than the enterprise. Even the enterprise, let's say for example, hotels and banking sectors. Each and every enterprise they have their own setup and own design. And if you did not do a proper setup or you brought up this proper design that consider the scalability and other feature, you might end up on some poor design setup where you need to invest more. Now, Cisco tried to standardize that by having this what is called the hierarchical design standard, where you have a access layer, and this is all the access switch in the environment, and you have a distribution layer to aggregate all the access layer, and a core layer to do the forwarding. And of course, also got changed. There is something called the collapse core design, where you have a core switch and access only, and excluding the distribution. There is a lot of, and of course, this is a standard. You can use that, and you can have your own design. Okay, so from the traditional network, you're not limited to one design. Hence, you have to consider everything when you designing your environment: the availability, the scalability, the redundancy. All these factors have to be considered when you do the initial staging at your network. Within Cisco ACI, Cisco came with a mandatory standard topology. It's called the spine and leaf architecture. In the spine and leaf architecture, there's only two layers in the environment. There is the leaf and there is the spine. The leaf main functionality is to connect the compute nodes, your server. The spine, and we will be knowing more, we're digging deep regarding this setup. The spine is to interconnect the leaf together. So it's a standard. You cannot bypass it. If you're using Cisco ACI, you have to consider the spine and leaf topology. Otherwise, the Cisco ACI will not work. And of course, the hardware that require is the Nexus 9K. So this is the standard topology for the Cisco ACI. Now, since we discussed the topology, let us discuss the component. Cisco, I will say the ACI fabric, it consists of the spine and the leaf. I would say the spine is giving reachability to the compute node, which are our server, or maybe an external routed domain, or a WAN connectivity. So this is the leaf. And the spine is giving the interconnectivity between the leaf. There is one rule here, one particular rule you should never forget. There is no spine-to-spine communication. There is no leaf-to-leaf communication. So spine only communicate to leaf, and leaf only communicate to spine. The spine and leaf, they are forming something called the IB fabric integrated overlay. The integrated overlay is like a decoupled layer of the actual routed or actual data flow, meaning that Cisco ACI in general is decoupling how the network flow works. There is data flow with an integrated IB fabric between the spine and leaf, and there is another layer, I will say, carried on this underlay to provide the reachability. So actually, you have an IB fabric, okay, completely isolated, that carried on all your data flow in the environment. It could be layer 2 MAC addresses, or could be layer 3. However, your environment had been decoupled into the overlay integrated IB fabric that form the adjacency between the spine and leaves, and between the actual data flow that require for server to server or endpoint to endpoint communication. Now, to summarize, the spine and leaf architecture introduces the following: simple and consistent topology, scalability for bandwidths. And when I say scalability, I say, like, if you want to increase, if you have a bottleneck, if you want to increase more bandwidths, that means more spine to leaf connectivity, symmetrical and optimization for forwarding behavior. And when we discuss that, we have mentioned that there is an overlay, there is a routing protocol that's running. There is IB to IB communication here. And we're using for this IB to IB communication a protocol called ICE. If you're familiar with the ICE protocol, you know it's you will be knowing it's a distance vector protocol, where it's used the SFP, shortest path first algorithm. And the SFP algorithm, they have some cool feature. It's called the equal cost multipathing, meaning that the more line you add to the between devices, the more I would say redundancy and failover happening, or equal cost, or I would say load sharing happening. Now, Cisco ACI, by having the IB by having the IB operating at the fabric overlay, and also have the spine and leaf architecture, now you have the capability to optimize all the links in your environment. Okay, and there is the least cost design for higher bandwidths. Okay, by the way, the spine and leaf communication, okay, it should be 40 GB or 100 GB. So there is a massive, it's a massive amount of bandwidth that you should consider, and that because that consider this acting as a backbone for your environment to connect all the servers together. Now, what my fabric composed of? The fabric composed of two critical protocols. The first protocol is the ISIs. The ISIs main functionality is to form adjacency between the spines and leaf and connect all the spines and leaf together. And why do we need to do so? Because each leaf they have their loopback IP addresses. We need to advertise all of this loopback to form a tunneling. And what sort of tunneling? Actually, it's a VXLAN tunneling. And why do we need to have VXLAN? The VXLAN will act as a data forwarder for our node, our server, our computer, our PCs in the environment. So all the nodes information will be carried on the VXLAN, tunneled, encapsulated, and tunneled via leaves. And each leaf, by the way, it's called the VTIP, Virtual Tunnel Endpoint. And there is tunneling protocol that's running on VXLAN tunneling, to be precise. Furthermore, all of these leaves, they need to know each other by the ISIs. So there is two main protocols that are required to form fabric adjacency. You have the ISIs, so the leaves and spine communicate to each other, and you have the VXLAN, which carrying all the nodes and the compute nodes information across the fabric. In this slide, we'll discuss more the functionality of the main component of the Cisco ACI. We have the spine switches. The spine switches represent the backbone of the environment. The main objective of the spine is to interconnect all the leaves together and exchange all the information about all the leaves to the other leaves. So the main functionality of the spine is like the backbone and interconnect the leaves. And now we have the leaves. The leaves actually represent the connection for our compute nodes. And when I'm saying the compute nodes, I'm talking about my server farm, my PCs. Now, you can say that the leaf represent the access layer in the hierarchical or the traditional hierarchical network setup. Also, the leaf node connect the APIC. What is the APIC? The Application Policy Infrastructure Controller. It's referring to the management server that unify all the policy together. So you have the APIC, which are the unified manager of the environment. You have the leaf, which provide accessibility to your compute node and servers, and you have the spine, which interconnect all the leaf together. Now, we'll discuss more about the fabric architecture. Now we understand how the fabric works. Let us discuss the architecture of the fabric. First of all, we have mentioned earlier that there is no spine-to-spine communication. There is no leaf-to-leaf communication. It's restricted to have a spine-to-spine communication or leaf-to-leaf communication or connection. Once you connect that, the interface will be disabled. You no longer will be the port will not be working at all. So it's high. I mean, it's very restricted to connect the spine together or the leaf together. That's the first thing. Second thing is the spine and leaf communication should be 40 to 100 gig fiber connection, of course. And those fiber are using a QSFP as a connector for the switch itself. And of course, each leaf should be connected to all the spine into your environment. You can scale up. I believe. I mean, it depends on the hardware that you're using. Each hardware, each model have a limited number of spine and leaf connectivity. You have to consider that when you do the initial staging and designing of your solution. Yes, we've mentioned that there is a spine to leaf connectivity. We mentioned also that the spine interconnect the leaf together. And the two main purpose of the leaf in the environment is to connect the compute nodes, which are the servers in the environment, as well as the APIC, which are the unified centralized management server in the environment. The APIC introduced a consolidated or unified way of automating, programming, configure, monitor, analyze the environment itself. The APIC cluster consists of 3 active clusters minimum. You can scale up to 5 and 7. We'll know why you need to have 3, 5, or 7, or odd number in general later on in our course. But at least you need to have a 3 active epic in the cluster, and you need to attach them, of course, to the Cisco ACI leaf in order to control your fabric. All of these components, the epic and the spine and leaf, represent a single fabric in the environment. In this slide, we'll dig deep inside our fabric and what is the protocols that running. Previously, we have discussed the ISIs, and we have mentioned that the main purpose of the ISIs is to exchange all the routing information between the leaves in order to advertise the loopback IP addresses, to establish VXLAN tunnels and exchange all the nodes information between each other. Also, one of the cool features of having ISIs is to use the by default built-in feature of the shortest path first algorithm, which is equal cost multipathing. ISIs provide this capability of utilizing all the links in the environment by activating the equal path multipathing feature. And that separates also the Cisco ACI from traditional network. Since ISIs now is deciding which path to be chosen, rather than relying on a spanning tree protocol, which at least block half of the network environment to eliminate any loop potentials. So we have ISIs in place. Also, we have another protocol which is called COOP, the Council of Oracle Protocol. The main functionality of the COOP protocol is to provide endpoint information to the leaf. Okay, now in order to understand that, we have to review how the traditional switching works. Actually, the traditional switching works. The traditional switching works by flooding the traffic and populating your MAC address table. Hence, understanding where is your source MAC address, where is your destination you're going to. The COOP, the Council of Oracle Protocol, is no longer relying on the MAC address table anymore. The entire ACI fabric is no longer relying on the MAC address table. Now, it used something called the endpoint table. The endpoint table contains all the information together, the MAC address, the IP address, all the endpoint information, that are connected to the leaf. And this endpoint information needs to be populated and advertised to the connected spine and accordingly to the other leaves in the environment. This is all the main responsibility of the COOP, the Council of Oracle Protocol. So you can consider the COOP is a replacement of the legacy traditional way of flooding the environment and populating the MAC address table. You no longer require to have a MAC address table in an environment. COOP can replace that by switching or replacing the MAC address table with endpoint table, and we'll dig deep about how the endpoint works in a later session. Also, one of the things that require, one of the building blocks of the Cisco ACI fabric is the multi-protocol BGP. The multi-protocol BGP is required to connect to the outside world. Now I have connection within our fabric. I have like quite understanding how the fabric interconnect, everything work together. Suppose that I need to communicate with the WAN, internet for instance, or branches or whatever I have. It will be the main functionality of the multi-protocol BGP to advertise the outside world to the fabric and vice versa. So the fabric use the multi-protocol BGP to communicate to WAN, use the COOP to build in the endpoint table to communicate internally, and use ISIs to exchange all the VLAN, exchange all the leaf information in order to establish VXLAN tunnels to do the forwarding. What is Cisco ACI Epic? Cisco ACI Epic is 3 servers forming a cluster that manage and control the entire fabric. Now, one thing you need to understand here, that if the entire 3 epics went down, you're only losing manageability to the environment. there is no traffic flow in the environment. However, you will not be able to manage the environment no more unless you have at least 2 active ABIC up and running in the environment. So the main purpose of the ABIC is to control or have some sort of policy orchestration within the fabric itself. You need at least three active server in order to form a cluster. 2 of them need to be alive in order to manage it. If you have only one cluster, if you have only one node, one ABIC node active in a cluster, you're no longer able to manage the environment. Simply, it's a UCS server. Okay, comes in 2 flavor: the M flavor, the medium, and the large. Okay, there is, I believe, now we have the M2, M3, and M4 coming to market. That's pretty all for the ABICs that you need to understand for the time being. Now, how the ABIC are connected? Each ABIC they come usually with the 2 bond interface, mean 2 pair of interfaces. One pair is for they call it the northbound traffic. One pair is connected, or 2 interfaces are connected into two different leaves to push all the instruction and the policies from the ABIC itself to the entire fabric. This traffic flow, we call it the northbound traffic. So I have a 3 server. Each server needs to be connected at least 6 leaves, where I'm connecting a single server to 2 leaves at the same time. These should be all connected. And this traffic flow or this connection is dedicated for the northbound traffic and sending all the policy enforcement instruction to the entire fabric. The other 2 pair of interfaces are used for out-of-band management, and this is used for the administrator in order to log into the ABIC itself and try to administrate it and do the day-to-day operation or day-to-day job that require and do the configuration required to be pushed down to the ABIC through, as we mentioned earlier, bond 0, which pushing all the northbound connectivity. Cisco ACI ABIC, as we mentioned earlier, you need at least 3 ABIC running in the environment in order to have an active cluster. And of course, they're working on active mode. In order to perform the active functionality, all the configuration are synchronized between the 3 ABICs. By doing a technique called the database sharding, what happens is each server partition a subset of the configuration, replicated and provided to the other server. So each server have a replica of its own configuration, as well as other replica from the other server communication. This is the way it can guarantee the synchronization of the configuration across all the 3 ABICs in the environment. And okay, we'll discuss now what is the hardware required. See, for the spine and leaf connectivity, each hardware or each role require a specific model or a specific series of Nexus 9K. Of course, the ACI relies only on the Nexus 9K to build up the fabric. However, the spine, they have a certain models or series for the 9K apart from the leaf itself. Now, the first model that we'll discuss here is the 9.5. 9.5 is considered as like the huge spine with the expansion, with a lot of expansion slot for future expansion and scalability. It comes with the supervisor engine and models. As we can see here, it's composed of supervisor engine, and you have the flexibility. It's a modular hardware where you can purchase an interface line card for future expansion. So you have plenty of expansion for the 9K, depending on the model number you're purchasing from the 9K series. Also, you have the fixed spine modular models, such as the 9364 series C, 64 meaning I believe 64 uplinks. Also, you have the 9332 series. All of these series, actually, I'm not good at the hardware. I don't fully memorize what's the hardware, but the main objective here is to understand that the spine require certain hardware model from the Nexus 9K. Not all the switches will work with you. You need a special. You need, first of all, you need to decide: are you going to have modular switch or fixed switch? If you're going to the modular switch, your only solution is to go with the 9500 series. Apart from that, you can go with the fixed lower series, which is starting from the 9346 series to the 9316 series. Okay, and those are the models that are required for the leaves. Of course, you can have a copper leaves or the fiber leaves. Apart from the QSFP and the spinal leaf connectivity, as we mentioned earlier, that the spinal leaf connectivity is mandatory to have fiber in the environment. So you can have a copper leaf for the compute node with additional fiber slot for the spine leaf communication, or you can have a full fiber leaf with the compute node that require leaf connectivity, as well as an additional slot for spine leaf. Now, I hope this has been informative to you, and we'll see you in the next slide, which is discussing the Cisco ACI fabric discovery.